Let's solve a challenging problem involving implicit differentiation of an inverse trigonometric function. We're given that ln y equals a times arcs in x, and we need to prove that 1 minus x squared times y2 minus x, y1 minus a squared y equals 0. Let's solve this step by step. First, let's rewrite the equation by exponentiating both sides to get rid of the natural logarithm. This gives us y equals e raised to a arcs in x. Now let's take the first derivative with respect to x. Remember, y1 represents dy dx. We'll need to use the chain rule here. The derivative of arcs in x is 1 over the square root of 1 minus x squared. Let's multiply both sides by square root of 1 minus x squared to simplify. This gives us y1 times square root of 1 minus x squared equals a times e to the arcs in x. And since y equals e to the arcs in x, we can substitute y back in to get y1 times square root of 1 minus x squared equals a y. Now, let's square both sides of the equation. This gives us 1 minus x squared times y1 squared equals a squared y squared. Here comes the crucial step. We need to differentiate both sides again with respect to x. On the left side, we'll need to use both the product rule and the chain rule. On the right side, we'll use the chain rule. Finally, we can divide both sides by 2y1 to get our desired result. 1 minus x squared times y2 minus x, y1 minus a squared y equals 0. And there we have it. We've proven the given equation through careful application of differentiation rules and algebraic manipulation. The key steps were using the chain rule correctly and keeping track of our substitutions.